Hey everyone, it's Justin again, and in this video, we're going to be learning about some common types of word problems. This will by no means be an exhaustive list of all the types of word problems and situations you might encounter, so we'll continue to look at more word problems throughout this course. Let's start with what's known as a break-even problem, a situation in which we want to know when two costs will break even or be the same. These situations come up a lot in both business finance and personal budgeting. Here's our example of a break-even problem. A membership to Gym A requires a $30 sign-up fee and then costs $15 every month. Gym B's membership has no sign-up fee, but costs $30 per month. How many months would it take for the memberships to cost you the same amount? Notice what the question is asking. When will something cost the same? This is the usual wording of a break-even problem, so let's solve it. First, we want to know when the costs of Gym A and Gym B will be equal. So we'll just write Gym A equals Gym B. Now we want to replace these with the actual costs. We were told that Gym A charges a $30 sign-up fee up front. So we're going to write down 30. We also know that there's an additional $15 charge every month. So we write 15M. The M means that it happens every month. So for 1 month, it would be $15. For 2 months, it would be 30. 3 months would cost $45, so on and so on. You just multiply 15 times however many months your membership lasts. So 15 times M. So that takes care of Gym A, but what about Gym B? Gym B only charges a $30 monthly fee. So that's just $30 times the number of months you're a member. So this is the equation that we need to solve. 30 plus 15M equals 30M. And we already know how to solve these kinds of problems, so let's just do it. Our only constant is on the left side. So let's get rid of any variables there. To undo adding 15M, we're going to subtract 15M from both sides. This leaves 30 on the left, and on the right, 30M minus 15M gives us 15M. Now we just need to undo multiplying M by 15 by dividing. 30 divided by 15 is 2. And on the right, the 15s will cancel, leaving us with just M. So M is 2. Remember what M stood for here, the number of months with a gym membership. So to answer the problem, if you had a membership at both gyms for 2 months, it would cost the same amount. Remember, it is always a good idea to check your answer. So let's set up the equation again and then plug in our answer, M equals 2. We get 30 plus 30 on the left and 60 on the right. These are equal, so plugging in 2 for the number of months caused it to break even. But to help us understand what makes 2 so special here, let's try plugging in different numbers of months and see what happens. So for only 1 month, Gym A costs more. For a 3-month membership, it switches, and now Gym B is more expensive. What's special about 2 months is that that is the one moment in time where both gyms cost exactly the same. They break even with each other. Next, we're going to do some problems dealing with distance. Yes, this is the stereotypical trains leaving a station problem that they make fun of. Train A leaves the station traveling at 120 miles per hour. Train B leaves an hour later, traveling at 150 miles an hour. When does Train B catch up to Train A? If we're trying to find when one train will catch up to the other, what are we actually looking for? We want to find at what time the train's distances from the station are the same. So in other words, we want to know when the distances break even. That's right, this is just another break-even problem. So how do we express each train's distance? Train A is moving 120 miles per hour, so the distance is traveled, it's just 120 times the number of hours that have passed, 120h. For train B, we would typically say 150 times the number of hours. But remember that train B left an hour after train A. So train B's number of hours will always be 1 hour less. If train A has been traveling for 2, train B has only been traveling for 1. If train A left 3 hours ago, train B left 2 hours ago. You get the point. So to say train B's time is 1 less than train A, we would write train B's time as h minus 1. Now that we've got the equation set up, let's solve it. First, we're going to need to simplify using distribution on the right side. 150 times h is 150h minus 150 times 1, so just 150. Since we've already got all of our constants on the right, let's get all of our variables to the left. Subtract 150h from both sides, and we will get negative 30h equals negative 150. Divide by negative 30 to cancel it on the left, and on the right, 150 divided by 30 is 5, and a negative divided by another negative is a positive, so those signs cancel each other out. So train B will catch up to train A 5 hours after train A left the station. Let's check that answer. We started with this equation, and we said our answer was 5 hours. 120 times 5 is 600, and on the right, 5 minus 1 is 4. And 150 times 4 is 600. So we got the same thing on both sides. If we look at the train's distances at different times, we see that at 4 hours, train B was behind. But at 6 hours, train B is ahead. At 5 hours, train A and train B have traveled the exact same distance. So that is the time at which train B has caught up to train A. Next, we'll do a similar example. What can I say? I love trains. Train A leaves the station traveling at 140 kilometers per hour. Train B leaves an hour later, traveling at 90 kilometers per hour. When will the trains be 290 kilometers apart? One thing we want to be careful of is that this time we don't want the distances to be the same. Instead, we want the trains to end up 290 kilometers apart. So for instance, if train A has gone 390 kilometers and train B only 100, then the distance between them would be 290 kilometers. Or if one was at 540 kilometers away and the other 250. The key here is that we want to subtract B's distance from A's distance, and it should come out to exactly 290. So now that we've got the setup figured out, let's complete the equation. Train A is moving at 140 kilometers per hour, and train B is moving at 90 kilometers per hour and leaving an hour later. Now to just simplify and solve. When we distribute here, we need to be careful because that minus is part of the 90. So we distribute negative 90 and get minus 90h plus 90. Combine these like terms and we get 50h. From here, it's a simple two-step equation. Subtract 90 from both sides, and we get 50 times the number of hours, which equals 200. So then we divide by 50, and we get h equals 4. At 4 hours, the trains are exactly 290 miles apart. I'll let you check the answer on your own this time. In this video, we've looked at a few types of word problems, but there are way more out there. It would be impossible to go over them all, but as long as you're thinking logically like we did in these examples, they shouldn't pose too much of a struggle for you. In the next video, we're going to look ahead to a future course, geometry, and we'll see how algebraic word problems can be used alongside shapes and figures. All aboard! Choo-choo-choo-choo-choo-choo.